What is up, you guys? Welcome to another episode on the Incredible Academics YouTube channel with the one and only Incredible Academic. Guys, listen, enough with the bragging. Let's get down to business. Today, I actually want to cover optimization, right? I don't want to do a lot, I just want to make sure that you guys are prepared, when optimization is concerned. Because it's not really that much of a big deal, to be honest with you. Okay, so please pause the video, take down the question. We're just going to be tackling it, right? So now that you have the question, you've written it down, right? So they're talking about this cylinder here, and they also gave the height over there. So we're looking at question 1 of this activity. So let's just read and see. Okay, a drinking glass in the shape of a cylinder. Okay, and obviously with optimization, they can either ask you to optimize volume or surface area. You must always be, on the lookout for that. And sometimes it's area. Area is still, along the lines of surface area. So you must know exactly what is area and what is surface area. You must understand what is volume. Unfortunately, with the grade 12s, most formulas are, given in your formula sheet. But obviously, if you don't know what's the formula for a cylinder, what's the formula for a hemisphere, for a sphere, this and that, it's pointless. So meaning that you have to do, you have to do homework. You must, go through the different shapes that we have, in grade 12, so that okay, what does the formula for a sphere look like, right? So that when it's given in your formula sheet, you don't struggle to identify it. Okay, so remember what I said. There's gonna be 3 types of optimization, 2 or 3, but the main ones being surface area and volume. Okay, you must know whether we're dealing with surface area or we're dealing with volume. And if you read the question properly, so a drinking glass in the shape of a cylinder must hold 200 ml. So the 200 ml, that is the volume. That's the space within that particular cylinder, right, when it is full. So find the value of R for which, find the value of R, right, for which the total surface area of the glass is at minimum. Can you see that now we're optimizing surface area? Otherwise they would have said such that the total volume of the glass is at minimum. Do you understand? So once you have established whether you optimizing volume or surface area, then that's when you can come up with the formula. Do you get what I mean? So now if it's a formula for volume, you go look for it. If it's a formula for surface area, you go look for it. Okay, so normally they will tell you something about surface area before they ask you to optimize volume, or they'll tell you something about volume before they ask you to optimize surface area. Do you get what I mean? Like these two, they actually work together, but you need to understand them vividly. Like you need not take chances. You get what I mean? But anyway, we're gonna tackle the question together, and hopefully you have it down somewhere. So I'm just going to be writing down the most important things here. Okay, so the 200 ml represents the volume. So I'm just going to write V is equal to 200 ml. Okay, but just saying V is equal to 200 ml is not enough, because this cylinder itself has got a volume, right? Now, what is the volume of a cylinder? You can look it through your textbook. The volume is given by pi r squared times the height. That is the volume. So now we already have something to work with, right? That pi, right? Pi r squared h is equal to 200. All right. This is exciting. We've set up an equation. All right. But now there's also something that they said about the surface area. Okay, they said something about the surface area. So what we are going to do is we now need to know what is the formula for the TSA for this thing. You can easily find it in your in your textbook. Okay, so the total surface area is basically the area of this top part, the area of the bottom part, and the area of the midsection. Okay, so usually TSA is like this. TSA for a cylinder is 2 pi r squared, right? Which is just the two areas for the circles, plus 2 pi r h. Okay, 2 pi r h. And really this, although this is going to take a bit longer, but I want to show you guys where the TSA is coming from. Even though, I mean, it might help when it comes to actually helping you guys remember the formula for this, because personally I'm not using any formula sheet. Why? Because I know how to derive the formula. I know why the formula is like this. Okay, so this is pi r squared. This is also pi r squared. Do you understand? So now we already know that the area for this is going to be pi r squared plus the pi r squared plus the midsection. But the length of this length here, it's actually 2 pi r, which is what? Which is the circumference. Okay, that's the circumference. Now the height is this. So if you multiply the 2 pi r h, which is the length of the circumference, this part here, which is basically the edge of the circle, this part here, that goes together with that circle over there. If you multiply the two together, that's just length times breadth, because you can see that this looks like some kind of rectangle. So the area for this part is just going to be 2 pi r times the h. So that's 2 pi r h. Okay, so if you sum everything together, it's going to be pi r squared plus pi r squared, which gives us 2 pi r squared. And now we also add, the area for the middle part, and then that's what we get. TSA is equals to 2 pi r squared plus 2 pi r h. Okay, so that's what we have, you guys. But this wasn't necessary. I was just trying to explain so that you guys understand what's happening here. Sometimes they will tell you that the thing actually has like the top is open. In other words, now your area is going to exclude this top part. Then it becomes pi r squared plus 2 pi r h. Okay, not 2 pi r squared, just pi r squared, because one side would be gone, right? So they spoke about the TSA. Now let's check what else is given. All right, so okay, I think that's all that we have. So remember, they said find the value of r for which the total surface area of the glass is at minimum. So everything needs to be in terms of r. Okay, so what we are going to do is we are going to make the h the subject of the formula, right? Why are we making the h the subject of the formula? Is because if you look at by the total surface area formula, the only thing that we don't want is the h, right? We already have it in terms of r, but we don't want the height. Okay, that's what we're going to make the height the subject of the formula this side, so that when we substitute this side, the height disappears and everything becomes in terms of r. Remember, the pi is just a number, so that's not a variable, so we need not stress about that. So we set up this equation before, so now we just need to make h the subject of the formula. Why are we making h? Remember, we're just trying to make that TSA formula to be in terms of R when I get rid of the H. So H is now equal to what? This is going to be, so H is going to be 200 over pi R squared. So H is equal to 200 over pi R squared. There you have it, pi R squared. Okay, so in other words, by the total surface area formula, we can actually replace the H with this. So TSA is now going to be what? TSA's, remember the formula is still the same, pi R squared plus 2 pi RH. Okay, and like with optimization, you guys, the approach is always the same, you know. It's always the same. You're always gonna have to make one variable to substitute the formula, substituting in the other equation, then you end up with the equation being in terms of one variable. Then you sort of like start doing the derivation and all of that with respect to that variable. So in this case, we're gonna be left with R, you know, as the variable of our equation, and that's what we are going to derive. Okay, because remember they said we must find the value of R, of which the surface area of the glass is at minimum. So you already know that, okay, if we must find the value of R, that means our equation must be in terms of R. So everything else needs to be removed. Okay, so now 2 pi R squared plus 2 pi R, and then remember we're removing the H, so the H is just 200 over pi R squared. Okay, so this then becomes 2 pi R squared plus what? The 2 and the 400, that's just going to be 400 pi. Okay, 400 pi, just 2 times 200 is 400, and then okay, the pi goes away because there's pi in the numerator and then there's pi in the denominator, so pi falls out. Then 1 R is going to cancel that R over there, so we just have 400 over R. I hope you guys are happy with that. So now what's going to happen is we are going to sort of like make sure that we don't have any fractions, plus 400 R to the exponent negative 1. So you see now our variable R is in power form, you know, throughout. So we're ready to derive. So we're going to say okay, power rule, 2 times 2 is 4 pi R, minus, we just multiplying the minus, and the 400 minus 400 R to the exponent minus 2. Okay, now obviously when we are deriving like this, we then set the whole thing to be equal to 0. Okay, so now it's just a matter of you know, solving the quadratic formula. You can see that this can be written in the form of mx plus c. Okay, I mean ax squared plus bx plus c, sorry about that. So now this is 4 pi R minus 400 over R squared is equal to 0. So to get rid of the fractions, we just multiply throughout by the R squared. So we're going to have 4 pi R cubed. This is actually working out pretty nicely. It's no longer a quadratic equation. You can see that now it's becoming cubic, which is actually way much easier to solve. So I mean, you guys are in grade 12, so I'm sure you can see that this is going to become R cubed is equal to 400 over 4 pi. Okay, therefore R is going to become the cube root of 400 over 4 pi. Okay, so we punch that into the calculator and we find the R. That's going to make our surface area to be at minimum. All right, so there you have it, and the answer is going to be 3,17. Okay, 3,17. All right, so that's it for today. I'll find another interesting question. Hopefully it's going to be a slightly different what we call a slightly different 3D thingy, so that you guys are not, we're not focusing on the same thing. So yeah, I'll find a different solid, and then we'll look at it. And I hope you guys enjoy the lesson. Until next time, shout out.